Hello, and welcome everyone. If you're watching this video, you missed day 2 of our week 4, and you're looking back to see what you missed. We talked about some common mistakes. I mentioned some hex colors, which is going to be covered in a second, and then lossless compression was the main topic of the day. You need to make sure you complete assignment 010901, which has to do with lossless compression, by Friday the 25th at midnight. Our objectives are, of course, to continue to use binary to represent different kinds of information. You guys are going to come up with some compression techniques for text, and you're going to evaluate the effectiveness of a heuristic. We'll talk about what a heuristic is, and contrast it with an algorithm. So let's go ahead and get started. I have graded a lot of your assignments. Please go and check to see what you got. You can make up any points you missed so far, so please do that. I'm not perfect. I could have made a mistake grading your work, so please double check, make sure everything is good. If you missed anything, make it up. Make sure you hit resubmit or resolve so that I know to look back at it. If you just stealthily fix it and don't tell me, I will not know and you will not get your points back. Most errors I saw are careless. Go slower. Make sure you read the assignment carefully. I'm getting a lot of people who just try to skim through and then you end up writing something that doesn't make any sense. We talked about creating digital images last class, so our warm-up today was to think about what kind of steps does a computer take, and I really wanted to lead it to this, which is this idea of abstraction in terms of different layers. So your image is really composed of all of these. The higher up we go, the more abstract it gets, and the lower down we go, the more concrete or physical we are. So this idea of abstraction is going to persist throughout our lessons, and you're going to see it coming back over and over again. Quickly about colors. In hexadecimal is a really neat and easy way to write colors, since each color on your actual computer is represented using 24 bits in total. It's really easy for us to use a system where we use 2 hexadecimal numbers instead of using 8 bits for each number to make it a lot shorter and easier to read. Please note that this is not a kind of compression, simply a different way to write this information. So we use 2 hexadecimal numbers to represent red, 2 for green, and 2 for blue. Of course, hexadecimal numbers go from 0 to F, so something like FF would be really bright red, and then CC would mean slightly less green, and 99 would be slightly less blue. And you can figure out what all these colors are by using various online resources. If you type into Google hexadecimal color selector, you'll get all sorts of different ways or different websites that'll show you what color corresponds to what code. And these are commonly used in various applications, so this is a good thing to keep in mind. The hashtag in the beginning simply signifies that what's going to follow is in fact a color and not something else like an address or any other kind of information. There are some videos on this PowerPoint that you guys can watch on your own if you would like. They're informative, but we don't have time in this video to play you other videos. I'd rather go through the whole material that I covered in class. So next we talked about compression. Compression is when you take a piece of information and you condense it to make it nice and short and easy to read and not have to type as much, right? Something like LOL is a lot faster to write than laugh out loud, of course. So what we did in class is we used this following widget, which I'll show in just a second, to take a series of words and compress them to take up less space. What does the widget look like? Let's take a look. So if you go to code.org, navigate to our classroom, which I'll do here, and then go to lesson 9, bubble number 2. That is where the widget is located. So lesson 9, bubble number 2. Here it is. The assignment we did today has to do with this particular application. How does it work? Over here on the left, you have the uncompressed text, well, to start off with. As we do stuff to it, it's going to become the compressed text. Down below it, this is your console that tells you how well you're doing compressing this information. And over here on the right is your dictionary. Please note that the dictionary is part of the whole message that you're trying to send here. So it takes up room as well. If you look at our size here, currently it takes up no room since we have nothing in there. And our actual text takes up 240 bytes. Now, how do we compress? Well, in order to compress, I can put things into my dictionary and everything in the text will be replaced with little symbols that represent whatever I want them to from the dictionary. So for instance, if I replace all instances of I'm with a sun, suddenly I have a situation where the compressed text has gotten smaller, but the dictionary note has gotten bigger. And in fact, I've replaced two instances of I'm with suns, but I didn't actually receive any compression as a result. I'm using the same amount of space. So compression is tricky. You gotta look for things that repeat a lot more. So for instance, if I do I underscore, now I've replaced some instances of I underscore with suns, and I've achieved a 2.5 compression rate. That's not very good, but we can keep going and create more entries in our dictionary to create different combinations. So if I put in wiser, that's probably not a very good one. Let's see, what else repeats multiple times? Ooh, didn't know repeats, right? So if I do didn't, I'm suddenly at 14% compression. Another thing you can do is you can create an entry that takes multiple symbols and compresses them into one. So for instance, over here I have sun umbrella for I didn't. I could Control C or right-click copy to take those symbols and place them Control V or right-click paste into my dictionary here, and they will become a part of it. So you'll see those instances were now replaced by a snowman. So now the question becomes, what is the best approach towards compressing? Is there a set of rules we can create that we can follow? And the answer is yes and no. So the idea of a heuristic comes up. Again, more videos that you guys can check out. So what is a heuristic? A heuristic is a loose set of guidelines that leads us to a good solution, not necessarily the best solution. So for something like text compression, you never quite know when you're fully done. Is the way you compress the text the best way? There's no way to know for sure. There might be a better solution had you started with different sets of characters to start your compression in the first place. So there's no way to know. Because of this, we can't really create an algorithm or a rigid set of rules that always gives us the exact right answer. But what we can do is we can come up with some guidelines that when we follow them, we get a pretty good answer every time. So that is what we're going for here. Now, how are we actually going to assess you guys on this? If you go to modules, as previously mentioned, there's an assignment for week 4 titled 010901. If you guys open this up, inside I ask you to develop a heuristic and share it with a partner. If you were in class, we did this. If you missed this in class, not a big deal. Just try compressing some of these. You don't have to compress all of them. Just try a couple of different ones and see what kind of compression rate you can come up with. Then answer the following questions. These are the part that I'm actually grading, so make sure you focus your attention on the questions. Don't spend your whole evening playing with the compression, even though it is pretty fun. All right, that is that. Now there is one more thing to go over here. This is called lossless compression, which means we don't actually lose any information. You can take your dictionary and substitute it back into the compressed text to get back any piece of information that you had hidden away or made smaller. That's not always going to be the case. Next week, we're going to look at something called lossy compression, where we actually forever get rid of something. There's one more assignment, which is the journal assignment, where this is going to be an ongoing thing where you keep track of your vocabulary throughout the class. This is posted underneath modules in week 4, 01.journal. It's going to be due next Wednesday, October 7th, and it's going to involve you defining the following 8 words. For each definition inside this assignment, I need you guys to come up with, first of all, the definition. You can use your own words or you can use a textbook definition. And then an example or a picture. And the idea is we're going to keep adding on to this as the semester goes on. And then hopefully by the time it's by the time you're ready to take the AP exam, we'll have a whole nice compendium of all the various vocabulary we've talked about, and you'll have nice pictures that you can look at so your brain can make a connection, and when you go to study, it's a lot faster for you than having to reread all the definitions, because I know that can be tedious. So I'm trying to help you out with this assignment. It is for practice and participation points, so as long as you do it, I will give you full credit, but you do need to do all the words, otherwise you're doing yourself a disservice. That's all I have for you today. I hope you guys enjoyed. Don't forget to do your assignment, and I'll see you guys next week. Have a good one.